Отлично. Следующий.
Okay, and here comes our next presentation, brought to you by Artem Ivanov, Atos IT SNS. Hello everyone, and thank you for having me today. Thank you for being here and not for eating instead. And let's start. My today's presentation will be about hardware, and let's talk what type of hardware is good for PostgreSQL. First, a traditional question for talks like this: who ran Postgres on 64 cores? And what about 182 cores and more? None of you. Okay, I think it will be interesting to you. So today we will talk about, well, briefly about agenda. I will tell you about our company. I will tell you about multi-core hardware configurations for Postgres. I will tell you about our solution for PostgreSQL for heavy configurations, and I will show you some areas of application in what customers are using our service. So a few words about us. Atos company 5 or 6 years ago acquired a bulk company. It was a company that was dealing with hardware almost 90 years. So now Bal has become a part of Atos company, and Atos is now a full hardware vendor. Here you can see our family, our products family, what we produce in Russia. Yesterday at our booth, you could see two servers, Sequana X and Escala. And I'm going to tell you about those services, and I will show you how these solutions can be applied for PostgreSQL tasks. So first, let's take a look at the market. Let's take a look how PostgreSQL deals with heavy tasks and why we need multi-core configuration. If we take a look at the stats, we see that PostgreSQL position is quite okay. In terms of open source solutions, this is the second DBMS in the world after MySQL. So the position of PostgreSQL is okay, customers are numerous, everything works fine. And what kind of loads are there for PostgreSQL? So there are transactional loads, OLTP loads that can be run concurrently. For example, we have a lot of hardware. We have populated our load across this hardware, we've made a cluster, and everything runs well on this cluster. But when it comes to analytics, it doesn't work fine as well as for OLTP. In analytics, we cannot run all the processes concurrently because everything goes to big machines, and we are going to increase our CPU capacity, memory capacity in terms of one server, not in terms of one cluster. So first approach that we use for OLTP is scale out, is when we just add additional nodes in order to increase performance. The second approach is called scale up. Scale up solutions are our service, and now let's switch to our solutions. So what our servers are capable to provide for PostgreSQL users. Last year I was delivering a presentation at the same conference, and I told you how we were using Boolean S16 for PostgreSQL. On Postgres website, my presentation is still can be found. Briefly, Alexei and I were talking about problems towards testing. We tested 8 CPUs, everything went well, Postgres was working greatly, but with 16 CPUs there were some problems. But what was the reason of those problems? Eventually we used some patches from Postgres colleagues, from Postgres Pro colleagues, and eventually 16 cores configuration has become completely available for PostgreSQL. PostgreSQL is now compatible with such configurations, and Boolean S16 server with 16 CPUs and 352 cores can work perfectly smoothly. Back in the days it was 4 terabytes of RAM, and next week we are starting testing next generation server with the 16 CPUs and 448 cores, and this is the latest solution that runs with latest Intel Cascade Lake CPUs, and we are going to use 6 terabytes of RAM. And we don't have any doubts that the testing will work smoothly, just because we have Russian customers who are using these same solutions, and I will tell you about them a bit later. So what BullSequana look like? In fact, this is like a constructor, and you can scale up by just adding 2 CPU modules, and BIOS sees this as a single system. So interconnectivity speed in such solutions is limited by CPU capacity, and interconnectivity speed equals to the UPI link throughput that is used in Intel CPUs. Here, in such solutions, we can scale up by 2 CPUs and by 3 terabytes. So the maximum configuration is up to 32 CPUs, and you can grow up to 48 terabytes of RAM. Such configurations find their customers. Currently we are deploying 16 CPU configurations, but I think that in the nearest future our customers will switch to this configuration. Apart from 32 CPU, 48 terabytes of RAM, you can use also up to 32 GPUs. In order to connect all the modules, when the configuration goes beyond 8 CPUs, standard Intel UPI links that are used to connect CPUs is not enough. In such situation, each vendor that wants to have their own solutions above 8 CPUs have to make their own power controller that will allocate additional UPI links and connect modules inside one server. We have such a solution which is called U-Box. It's a 5U solution that enables CPUs to talk to each other when it comes to configurations A CPU, CPUs plus. And this is how the U-Box schema looks like. In fact, for 2 CPUs we have one node controller, UNC. Each processor connects to node controller by UPI links, and all these 8 UNC controllers connect between themselves. So each CPU can talk to any other CPU, and the throughput, as you could see, is quite high. So there are 2 available U-Box configurations. The first one is when we provide one node controller for each processor. The second configuration is when we allocate not one node controller but 2 node controller for each CPU. By doing this, we can improve throughput, we can implement redundancy. If, for example, one controller fails or crashes, we can switch over to the second one. And also, we can duplicate UPI links and SCI links. Apart from Sequana as a server, we have power-based platform. This is a solution which is being produced in France as well. It is a solution that you can use with up to 64 gigs of RAM. It supports Power 9, Open Power, Linux, AIX, and also we've got a very interesting project with a splendid data company, and inside this solution we can help you migrating from Oracle to PostgreSQL. And just last year we have tested one of the Scala servers. TCP/H benchmark was used. It compares analytics, storage systems, and it consists of 22 different queries. They're different in terms of their complexity, and each of participants should go through all these 22 processes. You have to at least process them and try and do it as fast as possible. Our server that was equipped with the 2 CPUs with PostgreSQL 12.3. All 22 queries were processed successfully. If you compare our processing time to other solutions, our results were quite good, and this server is recommended, is highly recommended for PostgreSQL. And now let's talk about about case studies. In Russia, for instance, our main customers are from public sector. The very first installation of 16-socket solution, Cascade Lake, was done with the Sequana S. It was in Russian with this particular customer. And the system scalability is still going on, and I think that in the nearest future, 16 cores will not be enough, and they will grow to 20, 24, and maybe even 32 CPUs. So the main task was to support PostgreSQL. We also had to migrate all business software to this platform, and eventually 22 terabytes of RAM, 16 CPUs, and 384 cores. The same case was for Treasury of Russia. In total, it was 21 terabytes of RAM, 16-socket and 12-socket solution, and also the configuration can be scaled even higher. Apart from this, when we talk about Postgres solutions, it's not just about installing a box with some RAM and with some CPUs. Also, we need to help our customers with migration. We can help you with calculating of sizing, and we can give you a turnkey solution, not just a box. So we are providing you with the ecosystem and not just with the hardware. We are ready to show, we are ready to install, we are ready to help. Talking about demonstration capacity, we've got one of the biggest demonstration lab in Russia. We have a lot of servers based on Intel CPUs, Power CPUs that we are ready to give you for testing for different tasks, even with configuration with 6 or 8 CPUs configuration, or even more. So in total, what should you take away from this presentation? First, this solution scales up to the maximum number of CPUs with the smallest step, which is 2 CPUs per step, and you can grow up to 32 up to 32 CPUs. We are providing you with the most modern Intel technologies such as ECC, FPGA, and so on and so forth. Everything can be installed in our service, including GPUs, if you are going to train your neural networks or if you are going to implement AI or machine learning solutions. It's still about TCO optimization. You can cut your costs by in 3 or 5 years term, and as I said, it's a very decent experience that we have right now for you when it comes to 16 CPUs installations for PostgreSQL. You will not find a lot of companies with more than 16 CPUs for analytics. We've got this solution for you, and we also have use cases for 16 CPUs. So if you have any tasks that scale every year, and your sizing is quite big at the moment, please reach us out. We have a demonstration booth. We're ready to show you everything. We're going to describe you everything. We can show you the architecture, and we can show you a ready-to-use solution that will easily deal with all your analytic tasks. And that's it. Thank you very much for your listening, and should you have any questions, I'm ready to answer them. And here you can see my contact information. Thank you very much. It was quite interesting. So when you purchase hardware, you say we can scale it, but for example, we have budget. But what about compatibility? Because you say that some hardware can reach end of life. For example, we will buy some hardware, but in 2 years maybe it will reach end of life. What can we do with this? Will you just replace it or something else? So this type of server, end of support or end of life, will not happen in next decade. This server will be supported. It will be manufactured. When Intel launched new Cascade Lake CPUs platform, so we have replaced Skylake to Cascade Lake when these processors were available, and we are going to do the same when Intel releases a new series of CPUs. Current version of PostgreSQL, does it support NUM, non-uniform memory access? Yes, as far as I know, this feature is supported. Hello, I've got a question. So the synthetic test comparison slide shows Sunfire V240 from 2005. What can you tell us about this? So not a lot of servers were used in this benchmark. So that is why we are showing you what kind of service we used in this comparison. More interestingly, one of these servers was made in Russia. It is located in the very bottom, and we see that the results are quite good. Did you compare it to Spark service? Did you make a comparison of your service versus Spark, for example? You see this test was made for just a few solutions. So from our side, it wasn't an Intel-based platform, it was a Power-based platform. Our competitors didn't run through this test, but upon your request, we can show you different results. And we can compare our server to our competitors. We have these materials and we can share it with you. Thank you very much, Artem. Are there any more questions? If not, let's make some noise for Artem, and the next presentation will start in just 5 minutes. Thank you and stay tuned.